In the pattern recognition lecture series, so far we have talked about the introduction about pattern recognition, then the network based on Bayes theorem. Today we'll be moving to our next lecture, that is the linear models. So welcome everyone to this particular lecture, that is on linear models. So the lecture that was on the Bayes theory, that is dependent on the probability logic. So that is a probability. So those models that is based on the probability concept, those models are known as probabilistic models. These models can be of three types. One is the regression model, that is basically we are going to talk about. Then there was another type of model, that is the correlation model, that used to find out the similarity between two objects, that was the linear model. And another type of model, there are other types of model that fall into the other models category. Okay, so the regression model. So before going into the details of the regression model, let us just recapitulate something very simple. Based on these straight line equation, we'll be moving to the linear regression. So the linear models. So linearity, that's defined by the straight line. So what's the basic example or basic equation for straight line is that y is equal to beta x plus c. So let us understand what is the meaning of each of the components of this particular straight line. So the x is the independent variable. Y is the dependent variable. Beta is the slope, and C is the y-intercept. So these are the meanings of each of the components of the linear model. So let us graphically understand this thing. So what is the equation for straight line? Suppose the straight line is this blue particular line, that was the straight line. Where that is this particular direction, x values will be there. This particular direction, y values will be there. And this is the equation for the straight line. Now, what is the meaning of the beta? Beta is this thing, right? That is the slope. What is the C? C is the y-intercept. That is this particular blue line touches where at the x line, that is x-axis. So that is the y-intercept, that is the C. So how we can do the prediction using this straight line? That is, if you know something about x, then this knowledge helps you to predict something about y. So if you know certain values of the x, for that you can find the y value. That is the prediction. Based on this, linear regression or regression is drawn. Regression models have been drawn. The regression analysis is a set of statistical processes for estimating the relationships between a dependent variable and one or more independent variables. So dependent variable, that is x, and dependent variable is y and independent variable is x. So by this regression analysis, we can find the relationship between x and y. So just have the very simple regression model, that is the linear regression. So that is the equation of the straight line. So these blue dot points, each of the blue dot points are the values you know, that is given to you. Suppose there are 50 such blue points, that is you have for each of the 50 dot you have the x and y values. So you know the x and y value. So you have plotted those x and y value in this x and y plane. So just have one example. Suppose this particular. What could be the x and y? So x value is something like that. Suppose 27, 28, and y value will be suppose like 13 or something like that. So that value, that is the value x and y is given. So 50 such x and y values have been given, and you have plotted by the blue dots in the x and y plane. Now, by the linear regression, you are supposed to find out the red line. So this straight line is your linear regression result. So you can say that rather than doing this particular red line, can we draw another straight line? Yes, you can draw different straight line, but what will be your ideal choice for linear regression? That will be that we are going to discuss now. So suppose this is another straight line. Sorry, it's not a straight line, but assume it as a straight line. So this is another straight line, suppose. So how to find out that which one is the best suited straight line? Very simple logic is that from any of the known point, you need to draw a perpendicular on the linear regression result. This is the perpendicular as drawn. So by this perpendicular line, the length of this perpendicular, these you have to find out. For 50 such points given in the node, you have to find out this particular value. And you have to take in the summation of each of the error term. Now same thing you need to do for this particular straight line as well. So you are plotting one perpendicular from this point to this particular line. So this will be another 90-degree angle it forms, right? So this will be your another value you are going to get. So again you are going to take the summation of each of the point. So now these are the basic error values. So these error values you have to take that particular straight line for which the error value is the minimum. So that will be the linear regression result. So what summary we can draw over here is that linear regression models the linear relationship between a single dependent variable y and a single independent variable x using the equation y is equal to beta x plus c plus epsilon. The regression coefficient, that is the beta, reflects how much an effect x has on y, that is how much a dependency y has on x. And the epsilon term is the error term and is assumed to be independently, identically and normally distributed. So what is the meaning of the term normally distributed? That the mean will be 0 and variance will be sigma square. That is the epsilon. So that was the simple linear regression. But now suppose we are trying to do multiple regression. So for multiple regression is used to determine the effect of a number of independent variables. That is here only one independent variable x was there. But suppose there are more than one independent variable. That is suppose there are x1, x2, xn, that many number of independent variables are there. And we have to find out this particular effect of these many number of independent variables on a single dependent variable y. The different x variables are combined in a linear way and each has its own regression coefficient. That is, what is the regression coefficient? Beta is the regression coefficient. So each of the x has its own regression coefficient. So what will be the equation? Y is equal to beta 1x1 plus beta 2x2 up to beta lxn plus epsilon. The beta parameters reflect the independent contribution of each independent variable x to the value of a dependent variable y. That is the amount of variance in y that is accounted for by each x variable after all the other x variables have been accounted for. That is the multiple regression equation. So for the multiple regression, this can be the matrix representation. Now suppose you have j number of dependent variables, that is y has y1 up to yj number, and each of the y term, that is y1, suppose y1 depends on l number of independent variables. So y1 depends on x1, x11, x1l up to x1 a capital L value. That is each of the dependent variable depends on L number of independent variable and each has its own coefficient, that each has its own beta value. And this capital L value is from 1 to capital L and this small j value is from 1 to capital J. So how you can do the matrix representation? It's very simple. This will be the matrix representation of these many number of equations. So you have this matrix representation. So it will be row by column multiplication. So we are going to get these many number of equations. That is the matrix representation. So next class we will be talking about the parameter estimation in the linear regression. So thank you everyone for watching this particular video and happy studying.